Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. So now we're just going to get started on our set of questions for today's session. Okay, so the first question asks the following. What mass of water at 25 degrees Celsius must be allowed to come to thermal equilibrium with a 1.85 kilogram cube of aluminum initially at 150 degrees Celsius to lower the temperature of the aluminum to 65 degrees Celsius? Assume any water turned to steam subsequently condenses. Okay, so first I'm just going to write down all the values that they give us. The mass of aluminum is 1.85 kilograms. But I will also convert this to grams just to get everything in the same units. So 1.85 kilograms is the same thing as 1,850 grams. Okay, so they also give us a T initial for the aluminum. I'm just going to do delta T of aluminum is equal to 150 degrees Celsius minus 65 degrees Celsius. And I'll also write down the delta T of the water. So delta T just means the temperature difference. So the delta T for water is 65 degrees Celsius minus 25 degrees Celsius. So what we also need in this question is something called the specific heat capacity. And we need this because the equation that we are going to use is Q is equal to mc delta T. So Q is heat, and the amount of heat that is given off and that is being used will be the same for both the aluminum and the water. Mass was given to us, which is the aluminum, and delta T is what I calculated already. So like I mentioned earlier, we just need C in order to answer this question, which is the specific heat capacity. So this varies depending on the compound that you have. So first I'm going to look up the specific heat capacity of water. So C water is equal to 4.184, and the units are actually joules divided by grams times degrees Celsius. So usually this is given in the question, but we also need to know the specific heat capacity of aluminum. So again, I'm going to do C aluminum is equal to 0.900 joules divided by grams times degrees Celsius. Okay, so now we have everything we need to answer the question. So step 1, is to first solve for Q needed to equilibrate the aluminum. So again, it was using Q equals mc delta T. We just need to plug those values in. So Q is equal to 1,850 grams. And first we'll be looking at aluminum, so I'm going to use the C value for aluminum, which is the 0.9 joules over grams times degrees Celsius. And then I'm going to multiply by the delta T for aluminum, which was 150 degrees Celsius minus 65 degrees Celsius. Okay, so now that we did that, we can say the Q is equal to 141,525 joules. Okay, so part 2 of this question is to then solve for the mass of water. Okay, so just rearranging the Q equals mc delta T equation, we're going to do mass is equal to Q divided by C times delta T. So we're going to plug in the Q value that we found in the previous step. This time we will divide it by the specific heat capacity of water, which is 4.184 joules over grams degrees Celsius times the delta T for water, which is 65 minus 25 degrees Celsius. And now you'll notice that our units should cancel out, and we are left with a value in grams, which is 845.6 grams. You can also convert this to kilograms, so 0.846 kilograms. Okay, so let's see what the junior tutor said. They have the given values for the different heat capacities of both water and aluminum. First, solve for the amount of heat needed to equilibrate aluminum temperature. And they got 141,525 joules. Then using this heat, compute for the amount of needed water. And they also got 846 grams. Okay, so I can say this solution is correct.